So today we're going to cover Chapter 5, Section 2, and we're going to talk about applying congruence or congruent polygons. When we talk about congruent figures, we're talking about two figures that have exactly the same size and shape. All of the corresponding parts of one figure are going to be congruent to the corresponding parts of the other figure. So what we need to do is when we have two triangles, we need to be able to show that every single angle will match with the other angle in the other picture and every single side. So for example, in my picture here, let me see if white will show up better. I'm going to match. So notice angle A has the same marking as angle F. So I can say that angle F is congruent to angle A. I can also say that angle B is congruent to angle E because they both have the same congruency marking. And then angle C is congruent to angle D. You need to be able to match all three angles of the triangle. And now we need to go back and match all three sides, all the segments. So I'm going to show that the segments match as well. So side AB is going to be congruent to the same marking, and I'm going to say it's FE. And then I'm going to say that AC, the one with two marks, is congruent to FD. And then lastly, the BC is going to be congruent to the ED. When they ask you to list all the corresponding congruent parts, this is what you need to do. Now, it's also going to ask you to come up with a congruency statement. The congruency statement, the order matters. So you'll start out by picking some order for the first one. I'm going to pick alphabetical order, and I'm going to say triangle ABC is congruent. And now I just have to go back up here and look at the order that I put it here. If I went straight down ABC, then the second order here is going to be FED. Because the order, when you put it in here, angle A matched with angle F. And that's what we stated here in the congruency statement. And then I can say that angle B, it's in the second spot, it matches with angle E. And then lastly, I can say that C matches with D, and that's what I put here from the picture. So the order, when they give you a congruency congruency statement, it tells you what matches with what. So the order of this congruency statement is important to us. Now, at the beginning, we're going to need to show that every single angle and every single side matches. Later on, we're going to learn shortcuts where we don't have to come up with 6 different things that match. We're going to get away with only finding 3 things that match. So let's go ahead and look at our next theorem. It's called the third angles theorem. Everybody good on this slide? The next slide is called the third angles theorem. And this one states that if 2 angles of one triangle are congruent to 2 angles of another triangle, then automatically that third angle is also going to be congruent. So they'll give you 2 angles that are congruent. So notice they have A and D, they have the same markings, and then B and E. So by default, you can also say that C and F are congruent. And we saw this when we were using that triangle sum, where we added the 2 angles and then subtracted from 180 to find the missing one. So for example, so this would be the given. If these 2 are congruent, then you can conclude that the third one is congruent, and it's called the third angles theorem. If you want to abbreviate it and just put like a 3 third and then put angles theorem, you can abbreviate it that way. So for example, if I told you angle A was 20 and angle B was 80, I can go ahead and add those two. 20 plus 80, get 100, subtract it from 180, and my missing angle here is 80. And if these have the same markings, then I know this one's also going to be 80. You'll be using this theorem in your proofs. Everybody good on the third angles? Okay, let's do some properties of congruent triangles. So here comes these properties again, reflexive, symmetric, transitive. But now they're applying to triangles. So we already applied them to numbers. We applied them to segments, to angles. Now we can do the same thing for triangles. So again, reflexive is like a reflection. It's the same thing, is congruent to the same thing. Again, remember when you're naming a triangle, you either need to write the word triangle and then the 3 points or the 3 vertices, or you could put the little symbol for a triangle. Symmetric, remember like a line of symmetry. So these two match and these two match. And then your transitive, remember this would cancel out, and then you can conclude that the beginning is congruent to the end. And that's what they have here. So same properties that we've seen with variables, with numbers, segments, angles. Now they're applying them to triangles. Everyone's favorite, sometimes, always, and nevers. So complete with sometimes, always, or never. So the first one, an acute triangle is blank congruent to an obtuse triangle. This would be never. An acute triangle would never be congruent because an acute triangle needs acute angles, an obtuse triangle needs an obtuse angle. Okay, to be congruent, all the angles need to match. So when I put this, I'm going to put capital A. Since the lines are kind of small, I'll put a capital S for sometimes and a capital N for never. All right, next one. A polygon is blank congruent to itself. And this would be always congruent to itself. Let's see if green shows up. So this one was never. Next one, a right triangle is blank congruent to another right triangle. This one would be sometimes, because we could have, definitely it would have a right angle that matches, but the other two acute angles could be 40 and 50 or 30 and 60, and then it wouldn't be congruent, because congruent figures need to have all the angles match, same angles. Next one. If ABC is congruent to XYZ, then angle A is blank congruent to Y. So let's take a look at this. Let's match the letters. So here, if A matches with X, and if you think that B matches with Y, maybe I'll do a different color. Oh, pink doesn't show up. Let's do white, and then we'll just do black, C and Z. Now, if you think about it, you might say always, or never, I mean, but it is sometimes. And let me draw that for you. So let's say I have triangle ABC here. And let's call it XYZ. So we can see that A and X are supposed to match, and then B and Y are supposed to match. So you might think, well, A is not going to be congruent, but what if it's an isosceles triangle? This would be 45. This would be 45. So then they would be sometimes congruent. So this is when it would be sometimes. Because in this case, it is equal. But if they were different numbers, then that would be when it wouldn't work. Let's try the last one. If triangle ABC is congruent to XYZ, then A is blank congruent to X. So see how A is the first letter, and so is X. This one is always. In order for those two triangles to be congruent, A always has to be the same as X because they're both the first letter listed in the congruency statement. And it is an example of a trapezoid. And they want us to find the value of X and Y. Now, what's important here is this congruency statement that they've given me up here. Now, this one's pretty easy because both trapezoids are sitting in the exact same position. Sometimes you'll get questions where they'll try to trick you and they might flip one of the figures upside down. And then it might be more difficult to see what matches. So from the congruency statement, I can figure out what sides are matching. So for example, and you can also, in addition to the angles, so like for example here, A is going to match with F, and you can't really see the pink. Let me go ahead and do it in green. So A and F are going to be the same. So let's highlight A and F. Those are congruent. And then we can also do B and G. They don't have any measures, so we're probably not going to need B and G. And then C and H. C is 136. I don't know H. And then lastly, get yellow here. D and K are going to match. So that's 44. And K is the 4x plus 2y. All right, then I can also match sides from that statement. So if I want to figure out what matches with BA, notice BA here is the first two letters. So it's going to match with the first two letters here. Now these are sitting the same way, so it's kind of obvious, but this one is congruent to this one. That's the first thing I'm going to solve. So remember, when you're told that the two figures are congruent, BA is going to be the same length as FG. So FG is actually 9 inches. So to find the value of X, I'm going to go ahead and set up 3x minus 6 equals 9. I'm going to solve for X by adding 6, divide by 3, and X is equal to 5. So that's the first answer. Now, in order to do the next one, I'm going to use that X that I just found, and I'm going to set up my equation. Notice how I highlighted K and D in yellow, because K is the last letter in my statement, and so is D. So the equation I can set up to find Y is I'm going to set up 4x plus 2y equals angle D, which is 44. Now, I've got two variables, but I just found the value of X, so I'm going to plug that in here. So I'm going to do 4 times 5 plus 2y equals 44. I'm going to get 20. And now I can just move the 20 and divide by 2. So 2y is going to equal 24, divide by 2, and y equals 12. So again, you're going to look at the statement that they give you to see what matches. A word problem. It said Maggie took the piece of the fabric, STUV, shown in the diagram, and cut it on the diagonal to make a scarf for her and her friend. Are the two pieces the same size and shape? Explain. So in order to show if these two pieces of scarf, so we're talking about this piece here and this piece here. We want to know if these two pieces are congruent. Now, or the same size. So what we need to do is show that every single angle is congruent and every single side length. Now notice all the sides are already marked as congruent. So I'm going to first show all the sides that match. So I can state that side SV is congruent to TU. Actually, I'll do UT. And then the next one, and again, the order doesn't matter on the side lengths. And then I can also show that ST, because it has the 2 marking, is congruent to UV. And then this one in the middle here, realize that this is the one scarf and this is the other. And notice this SU is the same for both scarves. So I could state that SU is congruent to SU by my reflexive property. Now I need to go back through and find the congruent angles. So I'm going to go ahead and I can say V and T, they're both right angles. So angle V is congruent to angle T because they're right angles. And then the other two are going to be alternate interior. And the reason why I know that they are parallel lines is, remember, if you have 2 lines perpendicular to the same line, then the lines are parallel. So what I can state here is this line is parallel to this one. This is my transversal. So I could state that angle 2 is congruent to angle 3. So angle 2 is congruent to angle 3. And then the same thing, angle 1 is congruent to angle 4, because these are alternate interior angles because my lines were parallel. So I've now shown that all 3 angles are congruent in both scarves and all 3 sides of the scarf, making that these 2 pieces of fabric are the same size and the same shape. So this answer is yes, they are the same. And the last one is a proof. Again, we will be doing a lot of proofs in this chapter. Pretty good on example 3. Let's write the proof. Okay, I'm going to set up my statement and reason column. So statements and reasons. So I'm going to state all of my given here, and there's a bunch of the given. And I'm also going to add the congruency marks to the picture. So here I'm going to state that SV is congruent to RV. I'm also going to state that TV is congruent to WV, and ST is congruent to RW, and angle T is congruent to angle W. This was all my given. I'm going to go label my picture. So SV is here, and it's congruent to RV. And then TV is congruent to VW. And then ST is congruent to RW. And then it also told me that angle T was congruent to angle W. I need to get 2 more angles in here that are marked as congruent. So again, this is sort of like that bow tie. And know here in the middle, we've got these vertical angles. So that could be my next statement. Now, I cannot name this with I just can't call it angle V. I need to use 3 letters. So I'm going to call that vertical angle in the middle. The one on the top, I could say that that is SVT. So angle SVT, or you could have said TVS, it doesn't matter, is congruent. So SVT is going to be congruent to angle RVW. And this are vertical angles congruence theorem. I abbreviate that as VAT. Now, I just learned a new theorem today that if two of the angles in the triangle are congruent, automatically that third angle is also going to be congruent. So the last one, angle S, is congruent to angle R. And I can add markings to that one. Say 1, 2, 3, 1, 2, 3. And this reason is the third angles theorem that I just learned. And now every single angle, every single side has markings. So now I can conclude what I was trying to prove, that triangle STV is congruent to triangle RWV. And the reason is definition of congruent triangles. So once you've shown that every single piece, all three sides, all three angles are congruent, you can state that the two triangles are congruent, and the reason is definition of congruent triangles. And that is it for the notes on 5.2. Let me draw a line down here the middle to separate my columns.
What is VAT?
Vertical angles congruent. It's vertical angles theorem, or vertical angles congruence theorem.
How do you use the third angles theorem?
So notice I had already marked in my picture the blue angle T congruent to the blue angle W because that was given to me. And then I matched the pink ones there, the vertical angles. So as soon as you can show two of the angles in the two triangles are congruent, automatically that last angle is automatically congruent, and the reason is the third angles theorem.